In this video, section 4.2, Inequalities. Now, inequalities are relationships like less than, greater than, less than or equal to, greater than or equal to. These two are called the strict inequalities because the value is not allowed to be equal, whereas the other two, or equal to, these are called the weak inequalities. So if I had, say, x is less than 6, this means that x is, say, 5, 4, 3.2, negative 1,000, etc. Any number smaller than 6. Whereas if it's equal to, then I can take 6, and hey, it's allowed to be 6. 6 is less than or equal to 6. 6 is not less than 6, nor is it greater than. It's equal to. If we have the or equal to, we're fine. If we have a strict inequality, not allowed to be equal to. One of the things we want to look at in this section is solving inequalities. So let's set up a problem like this. 3x minus 4 is less than 14. Our solution is going to be any number that's less than 14 on this side. So if I have 3x minus 4 is equal to 13, I'm good. Whatever value of x that gave me that is fine. Whereas if 3x minus 4 is equal to 15, then that value of x is not good. So what I want to do is I want to say, what value of x makes this left-hand side equal to 14? Then, if I have any value of x less than that, I'm good. And if it's higher than that, well, I'm not good. So we're just going to go ahead and start solving. We'll add 4 to both sides. 3x is less than 18. Now we'll divide both sides by 3. And we'll have x is less than 6. So what when x is equal to 1? And notice that 1 is less than 6. Then we would have 3 times 1 minus 4. Well, that's equal to 3 minus 4, negative 1. And that's less than 14. So that's good. That's true. When we're on the less than 6 side, it looks like we get a true statement. Now let's try something like x is equal to 7. 7's not less than 6. And we're going to take that, again, substitute it in for x and see what we get. 3 times 7 minus 4. That's 21 minus 4, which is 17. And yeah, 17 is not less than 14. But that's just what we said. So that's good. That checks out. We said, look, x must be less than 6. When it is, we get a true statement. When it isn't, we get a false statement. So this problem is solved. This is our solution. And this is us checking our work. How about another one? Let's try minus 5x. We'll add 6 to it, and we want this to be greater than or equal to 16. So we'll proceed just like we did before. We'll just start solving. Subtract 6 from both sides, and we get minus 5x is greater than or equal to 10. Now we'll divide both sides by a negative 5. X is greater than or equal to negative 2. Okay, let's test this out. First, we'll take a number that is greater than negative 2. Say 0. And we'll have minus 5 times 0 plus 6 which is 6, and 6 is not greater than or equal to 16. Let's take some number like -3 that is not greater than or equal to -2, and we'll have -5 times -3 plus 6, that's to do positive 15, plus 6, that's 21, which is greater than 16. Well, this tells us that this shouldn't have happened. It should have been a true statement. And this means that this should have been false. What went wrong? It's backwards. Our solution is backwards. I'm going to try and solve again. Instead of doing the subtraction by 6 and all that such, let's go ahead and let's add 5x to both sides. On the left-hand side, we'll have minus 5x plus 6. These cancel, and we're left with just 6. On the right-hand side, it'll be 16 plus 5x. So we'll end up with 6 is greater than or equal to 16 plus 5x. Now, we'll subtract 16 from both sides. -10 is greater than or equal to 5x. Divide both sides by 5. -2 is greater than or equal to x. Okay. So the values of x that should work are anything that's less than a -2, like -3. And then we'll have -5 times the -3 plus 6. That's 15 plus 6, if you'll recall, which is 21, which is greater than 16. Woohoo. True. True. And over here, 0 is not less than a -2. So minus 5 times 0 plus 6, it's equal to 6, which is not greater than 16. True. The work checks out. So it looks like what we should have done is when we had to, when we did that division, we should have flipped the inequality. Why? That's that negative sign. So we'll write this out one more time. Minus 5x plus 6 is greater than or equal to 16. Minus 5x is greater than or equal to 10. Now, we'll divide both sides by a -5. These cancel out. We're just left with x, and we've got to flip the inequality. X is less than -2. And you have to flip whenever you multiply by a negative. And this means that if we had something like -x over 2 is less than 10, x would be greater than -20. We'd have to flip. A negative went to the other side, we're flipping. Flip the negative, flip the inequality. I want to take a look at one more example. 3 minus 2x, quantity divided by 7, plus 4 is less than -8. Now, what we're going to do, our plan of attack is to first get rid of the addition, then handle the division, then this addition, and then finally our fourth step is going to be to get rid of the multiplication. So to start off, we'll subtract 4 from both sides. Minus 8 minus 4 is a negative 12. And then that's greater than the quantity 3 minus 2x divided by 7. Next, we're going to have to multiply by 7. 12 times 7 is 84, and it's going to stay negative. Okay, now we're going to subtract 3. And we're subtracting from a negative, so this is going to be negative 87, not negative 81. Finally, we're going to have to divide by a negative 2. So we'll divide both sides by a negative 2. We'll have x is not less than, but greater than, because we need to flip. Negative 87 divided by a negative 2. Negatives cancel out, and this is x is greater than 87 halves. Okay. So like we said, first we subtracted, then we multiplied, then we subtracted again, and we finished up with the division. And notice how even though we were working with negatives all over here, everything that was going on was, with subtraction. This was subtraction, so we didn't need to flip. Multiplying by a positive, didn't need to flip. Again, addition, didn't need to flip. It wasn't until we multiplied by a negative that we needed to flip. Right there. Multiplication by a positive, we're fine. The fact that we are working with negative numbers, we're fine. It's that multiplication by a negative that means we need to flip the inequality. Alright, that's it for section 4.2. Thanks.